Here in this particular question, an electron moving with a velocity v equal to 1 into 10⁻⁷ meter per second I cap plus 0.5 into 10⁻⁷ meter per second j cap enters a region of a uniform magnetic field 0.5 millitesla j cap. Find the radius of circular path described by it while rotating. Does the electron trace a linear path too? If so, calculate the linear distance covered by it during the period of one revolution. So here in this particular case, before solving, so let me take a figure first, so that we can understand this one clearly. Suppose this is the case. As given information, according to the given information, so we have plotted a Cartesian plane, Cartesian coordinate system. So Cartesian coordinate system x, y, z. So three axes are there. So x-axis, y-axis, and z-axis, and this magnetic field which is given over here 0.5 millitesla, that is directed along y-axis. So that is directed along y. This is the direction of magnetic field which is along y direction. And another information which is given velocity of the electron. So let this pink color one represents, this round one represents the electron. This is our electron having velocity in xy plane. That means it has both x component and y component. So this is xy plane. Clear? So in this xy plane, this particle is moving. This particle is moving with some velocity as given here. So as this is moving in with some velocity, that means it will be having some x component and y component. Clear? So this x component of velocity is perpendicular to magnetic field. So here it is magnetic field is towards right, and this vx or x component of velocity of electron is outward. So that means they are perpendicular to each other. Here they are making 90-degree angle. So that's why this charged particle will experience a force F equal to q into v cross b. So using this formula we can express the force acting on the charged particle. And another component, this y component of this velocity which is along the direction of magnetic field. So due to that one it will not experience any force. That's why the electron will move along y direction due to the presence of that velocity. So due to the x component of velocity, and y this as magnetic field is along y direction, so it will experience a force. So direction of force, see, given by the cross product rule. So what is the direction of force? So we'll try to find out that one first. So the direction of force, if we move our fingers from first vector, that is velocity, towards magnetic field, then the thumb is pointing upward. So if it is a positively charged particle, then the direction of force will be along positive z direction. But as it is a negatively charged particle, so the direction of force will be along the negative z direction. So this is the direction of force, we can say. Okay, so force will be acting vertically in downward direction. Clear? So force along z, or you can say negative z. So here I am writing, so negative sign will be placed due to the negatively charged particle. So due to which what will happen is that this charged particle this charged particle will undergo circular path due to the x component of velocity, and linear path due to y component of velocity. So combinedly it will move like this. It will move something like let me draw the figure clearly. So it will move something like this. Clear? So that means it will undergo something like helical path. Clear? So this is called helical path. So what it is asked is that find the radius of circular path. So first of all, we try to find out the radius of circular path. So so here in this particular case, directly solving the question. So what is the formula for finding out radius? So as it undergo circular motion, so we know that centripetal force will be acting. We have to equate with this magnetic force due to magnetic field, and after that we'll be getting a formula for radius. That radius formula is r equal to mv upon q into b. Clear? So we're taking magnitude wise. So taking magnitude of the electron, charge of electron. So this v should be taken as the perpendicular component. That means it should be vx over here. Clear? So here mass of electron, velocity along that is the velocity along x, q, so that is charge of electron, and this magnetic field b. Here magnetic field is along y-axis, that is given, so no problem. So this, what is the radius? The radius mass of electron. So we'll try to find out the radius. So mass of electron is 9.1 into 10 to the power minus 31 into velocity along x-axis. Velocity along x-axis is given 1 into 10 to the power 7 meter per second. So velocity along x-axis is given 1 into 10 to the power 7 meter per second. Velocity along y-axis is given 0.5 into 10 to the power 7 meter per second. Magnetic field along y-axis is given 0.5 into 10 to the power minus 3 Tesla. Okay. So Vx is 1 into 10 to the power 7 divided by, we'll be taking charge of electron, that is 1.6 into 10 to the power minus 19 coulomb. Should be negative, but we are taking magnitude wise. So and the magnetic field is 0.5 into 10 to the power minus 3. Okay. So what will the result over here? So 9.1 uh, all divided by 1.6 into 0.5. That one, this will be taking this 0.5 into, so we'll be separating all these things into 10 to the power minus 31 into 10 to the power 7 whole divided by 10 to the power minus 19 into 10 to the power minus 3. Clear? So 9.1 upon here it will be 9, we can say it will be 91 upon 16. 91 upon 16, 0.5 is 1 by 2. That means the 2 will go up 2. This is 9.1, 91. This is 91. No, not 9.1. This is 91 upon 16 into 2. And this value will be approximately this 19. So it will be minus 22. Minus 22 plus 7 plus no, minus 22. That will go up. So it will be 29. So 10 to the minus 31. 10 to the minus 31 into 10 to the power minus not minus 10 to the plus 29. Okay, so finally how much will be getting? So it will be 288 approximately 11 point, we'll be getting something 11 point something will be getting. So let it be 11.37 something like will be getting into 10 to the power minus 2 here. So this will be the meter here. So finally radius of the given circular path what we are getting is 11.37 into 10 to the minus 2 meter. Okay. So while rotating, does the electron trace linear path too? Yes, definitely. Its answer will be yes. Clear. It will undergo some linear path. That's why we will be calculating. So calculate the linear distance covered by it during the period of one revolution. Clear. So what is the time period then? Question is that period of one revolution, period of one revolution. So period of one revolution, that is we can say over here, that is the time period. Time period formula is T equal to 2 pi m upon q into b. Clear? So if it is 2 pi m upon q into b, then distance covered, linear distance covered, that will be along which direction? That will be along y direction, not x. Clear? So linear distance covered along y direction. So y direction will be equal to, that will be vy into t. So velocity along y direction into time period. So what is the velocity along y direction? It is 0.5 into 10 to the power minus 3, not minus 3, into 10 to the power 7. So it is 10 to the power 7 velocity along y direction. Let me check first. 0.10 to the power 7. Okay, fine. 10 to the power 7 into time period is given 2 pi m upon qb. 2 into pi, the value of pi is 3.14 into mass of, we will be taking mass of electron. So that is 9.1 into 10 to the power minus 31 divided by, and this charge of electron, that is 1.6 into 10 to the power minus 19 into magnetic field is given 0.5 into 10 to the power minus 3. Okay, so we'll be doing the calculation. So 0.5, this 0.5 first will cancel out. So how much will be getting? So first take the values to one side and the power of 10 to be one side. So 2 into 3.14 into 9.1 whole divided by 1.6 into this one is 10 to the power minus 31, and here in the numerator 10 to the power 7 is also there, whole divided by 10 to the power minus 19 and 10 to the power minus 3. So we know that this particular value will come out to be how much? This will give you 10 to the power minus 2. Already we have calculated. So finally we have to calculate this one only. So how much will be getting? This particular one will be getting, let me calculate. So 2 into 91 into 3.14 upon 16. So it will cut by 8. So how much will be getting approximately? So it will be something like 11. 91 upon 8, that is 11.3. So it is 11.37, something like we are getting 37 into 3.14 into 3.14 into 10 to the minus 2. So how much will be getting? 3.14. Okay, fine. So if we do calculation of this one, so approximately we'll be getting like 33. So here 3, let it be 11.37, that will be 11.4, and here 3.14, let it be 3.2. So 33, so approximately 35 around we'll be getting. So 35, if we do calculate, uh, uh, 35 approximately, we are taking approximate value here, approximately 35 into 10 to the power minus 2. So 35 into 10 to the power minus, actually that particular value will be 35.7 into 10 to the power minus 2 meter. So linear distance, or you can say pitch of the helical path will be, this particular value will be 35.7 into 10 to the minus 2 meter. So this will be the answer for this one.